Hey guys, just a quick recap from the last video before we get into our next organic molecule called the alkenes. When looking at our alkyl groups before on our branched chain alkanes, if there are two identical branches, you use di, for example, dimethyl. If there are three identical branches, for example, three methyls, you call it trimethyl. And if there's four identical branches, for example, four methyls, that is called tetramethyl. Okie doke. Alkenes. Now, alkenes are organic molecules. They're hydrocarbons that contain a double bond. Right, so we're looking at double bonds. They all follow the same naming rules as the alkanes. For example, 1 carbon is meth, 2 carbon F, 3 carbon prop, 4 carbon bute, and so on. Except their name now ends with ene, E-N-E. So ethene, propene, butene, and so on. Obviously, you cannot have a double bond in with 1 carbon because there's only 1 carbon, and if it's bonded, to have a double bond, it needs to be bonded to another carbon, and therefore there's 2 carbons, so it'll be called ethene. So the first alkene is ethene, and when we draw our alkenes, we're going to draw them in a similar way we drew our alkanes, just a quick way. So if we look at ethene, for example, we've got 2 carbons. Right, and they're joined by a double bond. That means that each carbon only requires 2 hydrogens, not 3, like in our alkanes. Okay, so this is ethene, also commonly called ethylene. Now, the way that I want you to draw ethene and your alkenes is like this. H2 double bond CH2. Okay, because it's a lot quicker and easier. It doesn't take up as much space. If we move on to something a little bit larger, let's look at 4 carbons. When we've got 4 carbons, for an ethene that's got 1 double bond in it, for an alkene that's got 1 double bond in it, you can place the double bond in multiple positions, okay, which will it's still the same alkene, it'll just change the name slightly. Okay, so if we put the double bond here, right, then we only require a single H on this carbon here, because there is another bond here, and that makes 1, 2, 3, and 4. Here we still have CH2, and on the end we're going to have CH3. So this is 4 carbons, 1, 2, 3, 4. 4 carbons is bute. Right, it's going to be butene, but we're going to number our carbons. 1, 2, 3, 4. We start numbering from the closest side to the functional group. And the functional group in this case is the double bond. That's our alkene group. So we're going to name this but1ene with a dash like this, but1ene. Okay, because the double bond is on the first carbon, it's called but1ene. If we were to move the double bond to the second carbon, okay, we still have butene because we've got 4 carbons. However, now our double bond is on in between the second and third carbon, so it's on the second carbon, and we call this but2ene. Okay, now there are 2 different places that you can place the double bond in a butene molecule. If we were to move it here, then we would just renumber this butene, and we'd start from this side, 1, 2, 3, 4, and it would just be but1ene again. Okay, so this is but-2-ene. All of the same alkyl groups rules can apply to the alkenes. Okay, so for example, if we have 5 carbons, okay, and we put our double bond here, chuck a little branch up here. Okay. We're going to name this the same way we named a branch chain alkane, but this is just a branch chain alkene. Okay, so we've got a double bond here. We're still going to need to look for the longest chain, but we're going to count from the side closest to the double bond. Okay, we're going to count 1, 2, 3, 4, and you could go 5, but we're going to go 5 here. 5 is our longest chain, so we're looking at a pent. A double bond is on the second carbon, so this is pent-2-ene. Okay, and on our 4th carbon we've got an alkyl group. It's 1 carbon, so it's methyl pent-2-ene, and it's on the 4th carbon, so it is 4-methyl pent-2-ene. Okay, I just have to go turn the stove off and stir.